Hi, my name is Dmytro. I'm one of the technical leads on Pytorch team at Facebook, and I have been with the project since 2017. Today, I want to look back at what happened with Pytorch in 2021. We are going to cover three main topics. First and foremost, I want to recognize all of the people who helped to build Pytorch this year. Next, I want to go over major features that got released in 2021. And finally, I'd like to share some new ways you can get involved with the project. Pytorch is built by the community, and it wouldn't be successful without each one of you. Today, total number of contributors to Pytorch is over 2,000, an increase from about 1,500 from last year. On top of that, there is a huge number of downstream projects built on top of Pytorch. GitHub statistics show more than 90,000 repositories, double the number from a year before. Pytorch forums continue being an active venue for the community with more than 1,000 topics created per month. Who are all these contributors? Big chunk of contributions come from a diverse set of technology companies that have dedicated teams or individuals working on Pytorch. These contributions include new features, support for hardware platforms such as CPU, CUDA, or ROCm, dedicated backends like Onyx and XLA, or components like TouchServe and Profiler. But that tells only part of the story. About 40% of contributors are folks who don't necessarily work on Pytorch full-time. This includes AI developers, researchers, and just enthusiasts who all chime in order to make Pytorch better. Many of the awesome improvements and new features come from this category. I just sampled a few of them on this slide, like Sanchit Jain's contributions on bfloat 16 or Alexander Suarez's work to extract intermediate features for Torch Vision models using FX. I would probably run out of slide space trying to list everyone who contributed to Pytorch this year. It's important to note that no contribution is too small. Every small patch adds up to a better platform. In fact, more than 250 people contributed to Pytorch only once this year. Looking at the main Pytorch repository gives only partial picture. Pytorch has a lively ecosystem of projects maintained by various folks in the community. These include libraries for various AI domains with state-of-the-art paper implementations, tools and solutions for scale in production, high-level APIs, and so on. There are more than 70 key projects highlighted on Pytorch website, and more than 3,000 people made a contribution to at least one of them in 2021. And there are, of course, hundreds and hundreds more projects available on GitHub. Besides code contributions, I want to give a special shout-out to community members responding to user questions on Pytorch forums. In particular, Pyotr Bialecki continued to be the real hero, visiting forums every single day of the year and leaving over 7,000 responses. All of these things combined help to make Pytorch one of the most referenced frameworks in research. It's used in a huge fraction of paper implementations, and is cited with 2:1 ratio at ICML and 5:1 ratio at iClear. I want to thank every one of the contributors for making Pytorch great. This journey really wouldn't be possible without you. With that, let's look back at what happened with Pytorch in 2021. We had three major releases of Pytorch, featuring more than 3,000 commits each. And here are some of the highlights for the core library. We continued to improve coverage of NumPy operations, with significant progress done with APIs for scientific computing, such as linear algebra routines, special functions, and improved support for Fourier transforms. Of course, all of those are available on both CPU and GPU and have autograd support. Additionally, we expanded and made stable complex number support throughout the library, including the automatic differentiation, of course. On torsion and module side, we got support for deferred initialization of parameters, and ability to infer sizes of the weights based on input shapes, the latter one being courtesy of Emilio Castillo's contributions. Parameter reparameterization was also added, allowing for special forms of the weights. We also continued to expand low-precision operation coverage, with many int8 quantization operations added, as well as support for new bfloat 16 data type. Of course, there are many smaller fixes and incremental improvements, performance wins, and new operators. Hundreds of those happen every release. The past year also saw major additions to distributed functionality. Just to list a few here. GPU support for RPC communication, bandwidth and latency improvements for collective communication libraries, Drop-in support for sharded optimizer state, popularized by DeepSpeed 0, and pipeline parallelism building blocks. Revamped distributed launch experience with Torch Elastic Run. For mobile and embedded devices, we continued to push on smaller code footprint. We streamed down interpreter, and we expanded support for different backends and increased model coverage. On top of many improvements for individual operators, major features on performance side include expanded fusion for JIT, CUDA graph support, and many inference-focused optimizations. We released revamped Pytorch profiler to aid performance debugging. TorchFX now gives user power to do custom program transformations, and Torch Package and Torch Deploy bundle allows for performant deployment on server side without compromising flexibility. Besides features, there are also exciting updates on the platform side. Starting with Pytorch 1.8, ROCm pre-built wheels for AMD GPUs are available directly on website. This year, Pytorch Enterprise program just got started with Microsoft Azure being the founding member. TPU support for Pytorch XLA continued to improve, with Cloud TPU VM being a major game changer for easy to build performance training jobs. TPU support on Pytorch XLA continued to improve, with Cloud TPU VM being a major game changer for easy to build performance training jobs. And Onyx Exporter substantially improved the coverage with the latest offsets. There is a lot of exciting functionality of Pytorch currently in the works. It might not be ready for the prime time yet, but it is available on repository or in nightly builds as a prototype features. Some of the cool highlights here include FuncTorch, that brings composable differentiation and batching transformations, also known as VMAP, and allows you to efficiently compute per sample gradients, Jacobian enhancement computation, or do ensembling. Pytorch Composability Initiative continues to improve framework extension points. Just to name a few here: adding hardware backends outside of the main repository, easy integration with graph-based runtimes transparently in the eager mode with lazy tensor, and ability to experiment with new tensor-like extensions completely on the Python side. On the distributed side, sharded tensor support and general model parallelism primitives are currently in the work. And Torch Data project is aiming to make data loader more modular, extensible, and performant. Finally, I want to highlight a few ways how to better engage with Pytorch and get involved in the project. First, some of the ways to get up to speed on Pytorch development. As mentioned, forums is a place for questions on using Pytorch, but it's also a great opportunity to help other community members with answers and suggestions. This year, we also started Developer Discussion Forum, which focuses on Pytorch internals itself, and hosts technical reports and discussions. It serves as a complement to existing GitHub issues and RFC mechanisms. Finally, my colleague Edward Yan started an absolutely phenomenal podcast that dives into internal of Pytorch in a bite-sized discussions. With more than 50 episodes already available, it's a great way to learn rationale and trade-offs behind many features of the framework. There are many ways to contribute to the project, and no contribution is too small. Even a well-researched bug report with a convenient repro does go a long way. We take every contribution from the community with great care. If you looked at Pytorch GitHub, you may have noticed an elaborate system of labels and tags. In fact, it's there to enable a continuous on-call rotation we have for triaging incoming requests within a few days. All of this is to ensure that every issue and every pull request gets routed to appropriate module maintainer, gets read, and receives appropriate attention. That's a wrap for the short overview of Pytorch in 2021. Thank you so much for watching, and stay tuned for the deeper dives in some of the mentioned areas coming up next on Pytorch Developer Day.